Today we will read the different proof techniques. So, first we see that what do we mean by proofs and what to prove. First we introduce a mathematical system. A mathematical system consists of axioms, then definitions, a number of terms that can be predefined or some terms are newly defined. Now, we know that axioms. So, first we write the mathematical systems. You can write that it is a set of axioms then some definitions and a number of terms. Now, these axioms we can think that it is assumed that they are already proved, some statements, or we can tell some theorems that are already proved. So, axioms are assumed which are already or we can write directly are assumed to be proved. In definitions, are used to create new concepts and terms that are explicitly defined as well as can be implicitly defined for mainly for axioms. So, we define a mathematical system mainly by these 3 parameters. Now, we can think the theorems that can be treated as a proposition which has already been proved or we have to prove that proposition. So, we define or that theorems can be treated as the propositions. Since now we know the proposition we have read in logic. So, as if theorems we are thinking as a proposition which is that has already been proved. Or we have to prove. Or the now proposition is to be proved means the truth value, or we can tell that the proposition is true, that is the proposition, we have to show that proposition is true. That means, the truth value of the proposition is true. Now, an argument that establishes the fact that this proposition is true is a proof. So, we define the proof, we define proof as an argument that establishes the truth value of the proposition Now, this argument that can be defined or that can be presented in different way, and that we call that there is this different way of establishing or the different way of arguments, these are called the different proof techniques. So, different arguments or different form of arguments mainly are the different proof techniques. Now, already from our previous knowledge we know the terms lemmas or corollary associated with theorem. So, lemma and corollaries, these are again we can treat that as the different form of theorems. We know that lemma mainly this is also a theorem, it is also a theorem which is not very important to prove, but is very useful to prove another theorem. It is also a theorem which is useful to prove another theorem. And we can tell corollary. Corollary is another theorem it is also a theorem that derives or it is derived from another theorem very easily. Which is derived from another theorem easily. So, with these basic definitions of a mathematical system, that mainly in a mathematical system that we will define the different terms, and then using those terms or definitions will state some theorems or some statements, since now the theorem means it is nothing but a propositions to be proved, and then we will see how we can prove that statements, or how we can show that the proposition, the truth value of the proposition is true. So, before we give the different proof techniques, first we see how the theorem can be treated as a proposition. So, the general form of theorem. So, I can write that for all terms I write for all values of x, if p x1, x2, xn, then q x1, x2, xn. So, this is some universally quantified statement. So, the general form of theorem is a nothing but a universally quantified statement. Now, this is my hypothesis, this is my hypothesis, and this is my conclusion. So, given this proposition that if P is true, what is that proof? What we have to prove? That if P is true, that means all x1, x2, xn which are in the domain of discourse D, if P is true, we have to show that Q is true. So, we represent the theorem like a proposition. Since now we know, we have read the logic and we know that what is proposition and what are the truth values of the proposition, or what are the different logic rules or the laws of inference or different other rules we can apply to derive or to show that some conclusion to be true or false. So, we have to now we read that how we can do the proof. So, first we see that a direct proof is very simple, always we use. So, the name is direct proof. So, direct proof, if P is true, that means the hypothesis, we assume P is true, or better I write using P is true, since here already it is given. So, using P is true, and with the help of other axioms definitions and the previously derived theorems and the previously we have to show that Q is true, the conclusion is true. So, this is mainly the direct proof. So, we see one example of the direct proof. We give the statement that if M is odd, and N is even, then show that M plus N is odd, where M and N are two positive integers. Now, what definition is required? All of we know the what is odd and what is even, but it has some proper definition. So, what is an odd number? We know that M is an odd number if there is one integer k1 such that M equal to 2k1 plus 1. Similarly, I can define an even number. So, N is an even number if there is one integer, say k2, such that N equal to 2k2. So, these are the two definitions, prior definitions, or these are our previous knowledge that we need to prove this statement or to prove this theorem. So, what is then m and n? Since given m is odd and n is even. So, m plus n in terms of k 1 and k 2, we can write 2 k 1 plus 1 plus 2 k 2 is 2 k 1 plus k 2 plus 1. So, k 1 plus k 2, that I can write a k, an integer where k equal to k 1 plus k 2. So, this is of the form of odd, because we have defined m equal to 2 k 1 plus 1. That means, for integer m plus n, there is one integer k equal to k 1 plus k 2, such that m plus n equal to 2 k plus 1. So, this is some odd number. This is one odd number. So, it is proved. So, the theorem is proved. So, this is one direct method of proving the statements. Okay. Then immediately we have to think that if there is a direct method, then there must be one indirect method. So, what is that indirect method? So, indirect method normally is some proof we do by the method of contradiction. That contradiction we have read in a study of logic. So, mainly the proof by contradiction or a special case of contradiction is called the contrapositive. Is the method of proof by indirect way, that means indirect method of proof. So, how we define this technique? So, our theorem, now we know that if P, then Q. This is the proposition that we want to prove. Now, here we assume that, because we have to prove that Q is true. Okay. I write, we have to prove that Q is true. So, we assume Q is false. That means, negation Q is true. So, using P, that means P is true, negation Q, and with the help of axioms, definitions, and previously derived theorems, will show contradiction. What is contradiction? We have to show q is true, but we assume negation q is true. So, we will show a contradiction and we will prove the theorem. So, the difference from the direct method is that in the direct method, directly we have taken that the hypothesis is true, and from there only, and with the definitions or previously derived theorems, like the previous example we have taken the definition of odd numbers and even numbers. In addition, here in proof of contradiction, we assume that our conclusion is false, and from there we will derive that thing. So, we take one example. See, for if x y are two positive integers, if x plus y greater than equal to 2, then x greater than equal to 1 or y greater than equal to 1. Now, here or if p then q. So, x plus y greater than equal to 2, this is my hypothesis p, this is my hypothesis. Q, my conclusion is x greater than equal to 1 or y greater than equal to 1. So, this is my conclusion. So, for contradiction or indirect proof, we assume negation q. So, what is negation q? Negation q is negation, which is equivalent to negation x greater than equal to 1 or y greater than equal to 1. So, with logical symbols we can write. Then we apply De Morgan's law. So, this becomes negation x greater than equal to 1 means x less than 1 or becomes and y less than 1. Now, we know that we have p is true, that means because we have to use p true, then negation q and the definitions or the previous knowledge and the previously derived theorems, okay. Axioms, definitions, etc. So, p is true means that x plus y greater than equal to 2, and negation q means just now we got that x less than 1 and y less than 1. what is x plus y? X less than 1 and y less than 1. So, x plus y less than 1 plus 1, that means x plus y less than 2. Now, see that P is true. So, my hypothesis was that x plus y greater than 2. This was my hypothesis. And now, we got from negation q, we got x plus y less than 2. So, this is a contradiction. So, we get or 1 and 2, from 1 and 2 we get a contradiction. So, that means what we assumed, that negation q true, we assume that negation q true, that is false. That negation q, actually this is false. So, q is true and it is, the theorem is proved. So, we can define the contradiction in this way, that if P implies Q, if P then Q, that means P implies Q, this is my proposition, P implies Q, that implies P implies Q implies R and negation R. So, our theorem to be proved is P then Q, which is if P then Q, which is P implies Q. Now, P implies Q, from there we take P true and negation Q, and if that implies one contradiction, that means some proposition R and negation R, then this is a contradiction, this is a contradiction. So, this is if we get P implies Q implies R and negation R, that means contradiction, then this is actually the basic principle of, this is my basic principle of the proof by contradiction. This is proof by contradiction. So, we see in this lecture we have read the very basic techniques of proof, or very basic proof techniques is direct method and the indirect method, and mainly how the theorems are represented as a proposition and then how they can be proved, or the truth value of the conclusion can be made if the theorem is represented as a proposition.